All right, now recording. So recording now. So we're moving on in our topic of derivatives, and the rest of the chapter is mostly derivatives, derivatives, and more derivatives. Okay, let me try to share the screen here. Okay, so this is where we're at in our modified schedule here. So we are here, right? So 9.4 today, 9.5 Thursday. If we go one section a day, then this is where we're at. And then next week, 316, 9.6, 318, 97, and 323, 99, and then the next exam on the 25th. And that's a perfect time to have it because then we have our spring break a week off after that. Okay, so last time we did derivatives, it was a very difficult formula. Okay, but fortunately, the rest of the chapter, you won't have to do very much of that limit h approaches 0, f of x plus h minus f of x all over h stuff. Okay, we're going to have nice shortcuts. Okay, so today we're going to learn all the various shortcuts for derivatives. And for most of the rest of the time, you can just go straight to the shortcuts. We will not prove the shortcuts. If you were to take a formal calculus class, like the Math 100 series or the 110 series, they might actually prove these laws for you. How do you prove them? By using, the formula we had last time, limit h approaches 0, f of x plus h minus f of x all over h stuff. Okay. So we're going to learn all these shortcuts, and then quiz on Thursday will be on shortcuts from today. So basically 9.4. Now I'll give you more shortcuts on Thursday, 9.5, but whatever I give you new on Thursday will not be on the quiz. It'll just be on today's material. Okay. So let's go straight to the shortcuts. And let's see, some people just joined. Yeah, anybody who joined late, or if you think I missed you, just put it in the chat and I'll get it a little bit later. Okay. So we'll go ahead and get started. So where are we? We are now here. So 9.4 in my book, 1 to 33 odd, 47, 48, 53. Okay. So here we go. So last time we did this for derivative, right? Page 562 on my book, derivative, f prime of x, limit h approaches 0, f of x plus h minus f of x all over h. We're hardly ever going to do that anymore, okay, because we'll have the shortcuts. To prove the shortcuts, you would do this, okay, but we're not going to. Okay. Again, if you took either the Math 100 or 110 series at City College, they might prove it for you. Okay. And what are these derivatives for? On my page 566, if you ever see this kind of language, velocity, instantaneous rate of change, marginal. It says marginal revenue, but it's marginal anything, marginal profit, marginal cost. It means derivative, and slope of the tangent to the graph. It all means the same thing, derivative. Okay. All right. So here we go. Derivative shortcuts. So I'll give you my version, and I'll show you the book's versions also, and then we'll do some problems. So 9.4 derivative formulas. As usual, ignore any dates. This is from last time. Okay, suppose you have f of x equals a constant. K is for a constant. So all you see is a number, 7, 25, a million, negative a half, or whatever. Okay, now in algebra, they look like horizontal lines. Okay. Derivative means slope. So what's the slope of a horizontal line? 0. Okay, so first rule, the derivative of a constant function, derivative of a constant is 0. F prime of x is 0. So if all you see is a number, the derivative is 0. Okay, so what's the derivative of y equals 7? 0. What's the derivative of f of x equals pi? 0. Okay, if all you have is a number, its derivative is 0. Easy enough. Okay. And I'll raise it up for focusing purposes. Okay, next is if you have a linear function, mx, y equals mx, f of x equals mx. Okay, so what about mx plus b? We'll get to it, but let's just start with mx. The plus b will come in time, as we'll see. All right, So when I write it like this, mx, what's the derivative? Well, derivative is slope. What's the slope of this line? M. So f prime of x is just m. Okay. So if you have a linear function, something times x, the derivative is just a coefficient. Okay, so that means what's the derivative of 2x? 2. What's the derivative of negative 5x? Negative 5. If it's a linear function, that means all you see is mx. What's the derivative of 1,000,000x? 1,000,000. What's the derivative of negative a half x? Negative a half. Okay, derivative means slope. So slope y equals mx. All right, you can kind of see these. Okay, I cannot show you the next rule, the power rule, except to say it is provable. You can do it by the limit definition that we had before, limit h approaches 0, f of x plus h minus f of x all over h and all that stuff. Okay, so this one's called the power rule. Okay, so this is a biggie, pretty big one. If y equals x to the n, y prime is n x to the n minus 1. Okay, so the exponent comes down in front. X raised to the new exponent, you take away 1. You subtract 1 from whatever was up here. This is the power rule for derivatives. Okay, x to the n. Exponent comes down in front, and then x to the subtract 1. Examples. Suppose f of x is x cubed. The derivative, f prime of x, 3 comes down, x squared. You subtract 1 from the exponent. So the derivative of x cubed just becomes 3x squared, like that. Okay. Another example, y equals x squared. Okay, you'll see me write this sometimes, dy dx. It looks like dy over dx, but we just say dy dx. It still means derivative. Okay, so there are 3 main symbols for derivative: y prime, apostrophe prime, f prime of x, and dy dx. They all mean the same thing. So you'll see me mix them up. Okay, so I'll write it like that. I'll write it like that. I'll write it like that. They all mean derivative. They all mean the same thing, derivative. Okay, so 2 comes down. X to the 2 minus 1 is 1. But if the exponent is 1, you usually just leave it off. So the derivative is 2x. Okay. Another example. F of x equals x to the 10th. What's the derivative of x to the 10th? F prime of x. So 10 comes down. X to the 10 minus 1 is 9. So 10x to the 9th power. Okay. This rule even works. It works for all real numbers. That means it also works for fractions, decimals, negatives, and so on. And I'll show you some of those also. Okay. Okay. Y equals x to the 2.3. What's the derivative? So y prime is 2.3 comes down, x to the 1.3. 2.3 subtract 1, 1.3. Okay, so this is called the power rule. A lot nicer than keep doing, limit h approaches 0, f of x plus h minus f of x all over h, all that stuff. Okay, how do you do a square root? F of x equals square root of x. Well, from algebra, recall that square root of x means x to the 1/2 power. Okay. This is the power. This is the root. So the exponent is understood to be 1. The root is understood to be 2. So x to the 1/2. Okay, so f prime of x, 1/2 comes down. 1/2, x to the 1/2 minus 1. 1/2 subtract 1 is negative 1/2. And then clean it up. The negative means put it in the denominator, and the 1/2 means square root. So the best way to write the final answer is 1 over 2 radical x. Okay, the negative means put this in the denominator, and the 1/2 means square root. Okay, so the derivative of square root of x is 1/2 radical x. Okay, one more like that before we go on to another rule. How do I differentiate? By the way, you hear me say differentiate. Differentiate means take a derivative. Okay. Yes, there's an English word differentiate, right? Like to distinguish between something. If you hear differentiate in calculus class, though, it means to take a derivative. Okay, so technically we don't say derive as the verb. The verb form is differentiate. I'm not really testing on that. I'm not testing on vocabulary, obviously, but just, just to get it right. All right, so how do you differentiate 1/x? So write this as x to the -1 power, right? 1/x means x to the -1. And now I can do the power root. So dy dx means derivative. Okay, -1 comes down. But if it's -1, you can just write negative, right? X to the -1 minus 1 is a -2. And then clean up the algebra. Just bring that down to the denominator. So -1/x², final answer. Okay. Okay, the next rule, it's a constant multiplier rule. What if you have a coefficient in front of something? So c, which is a number, a constant, times f of x. How do you differentiate that? Just keep the constant, the number, c times f prime of x. This is the constant multiplier rule, sometimes called the coefficient rule. If you have a number times a function, the derivative is the number times the derivative of the function. Okay, it's fairly straightforward. Give you a simple example. Okay, y equals 7x cubed. Now we already know how to differentiate x cubed. What was the derivative of x cubed? 3x². So how do I differentiate 7x cubed? It's just 7 times the derivative of x cubed. That's the way the constant multiplier rule works. It's pretty intuitive. Okay, so 7 times 3x², which is 21x². And now if you look back at the beginning, the shortcut is, oh, okay, I'll just take this number times this number. 3 times 7 is 21, and then subtract 1 from the exponent. Okay, for the constant multiplier rule. Right, so if you see something like this, just multiply these two numbers. 3 times 7 is 21, that's a new coefficient, and then subtract 1. Okay, some simple examples. Suppose f of x is 2x to the 5th power. What's the derivative? Just go 2 times 5 is 10. X to the 5 minus 1 is 4. So 10x to the 4th. Okay, a little bit harder. Suppose y equals cube root of x. Cube root of x, this is the original problem. What's the exponent? It's understood to be a 1. I got that in red there. So how do I write this as a fractional exponent? 3x to the 1/3. Okay, remember the number on top is the power. The number on the bottom is a root. Okay, 1/3. 3x to the 1/3. Power over root. My memory trick is the root of a tree, the root of a plant is further down, right? So the one that's the number that's down is the root. All right, so now I do my constant multiplier rule. I multiply this. What's 1/3 times 3? 1/3 times 3, 1, which means I don't even have to write it. The new coefficient is 1. X to the 1/3 minus 1. 1/3 minus 1, 1/3 minus 3/3 is -2/3. Okay, and then you can rewrite that. We're not supposed to leave our answer with negative exponents. So 1/x to the 2/3. Okay, I'll accept it like this, but if you want to rewrite it back as a radical, 1 over cube root of x². Remember, this is the power, this is the root, so the root is 3, the exponent is 2. So you can also write 1 over cube root of x². Okay. Now, one exception about the negative exponent rule, I think I've mentioned this before. If your problem starts off with a negative exponent, you may leave it as a negative exponent. Okay. I mean, it sounds hypocritical to say, oh, you got to have your answer without a negative exponent. And the problem starts off with a negative exponent. So if the problem starts off like that, you may leave it as a negative exponent. Therefore, when I want f prime of x here, I just go 3 times negative 4 is negative 12, x at negative 5, and you may stop. Because the problem starts with a negative exponent. I can leave it with a negative exponent. Now, if you want to keep going and put that in a denominator, though, I'll let you. So if you go negative 12 over x to the 5, that's still going to be okay. All right, one more, and then we're ready to start some problems. Is what if you have a sum or a difference? Okay, it's not that hard. You can probably guess what to do. Okay, I now know how to take the derivative of 9x cubed. I know how to take the derivative of 5x squared. I know how to take the derivative of negative 7x, negative 7. I now know how to take the derivative of 6, 0. Right? Okay, so guess what should I do if I want the derivative of the whole thing? So if I want the derivative of the whole thing, how about just take the derivative of this plus the derivative of this minus the derivative of this plus the derivative of this? That's exactly what you do. Just go down the line and add or subtract whatever you need. Okay. So derivative of 9x cubed. 9 times 3 is 27, 27x squared. Derivative of 5x squared. 5 times 2 is 10. 10x to the 1, which is just 10x. Okay, derivative of negative 7x, that looks like this one, mx. So it's just going to be the coefficient. So what's the coefficient of negative 7x? Minus 7. And the derivative of 6 is 0. So if you're adding 0, you don't have to write it. Okay. So there we go. Okay. Question in the chat about how would I write this if I were to keep going? Then just bring the x at negative 5 into the denominator. So I'm going to go like this. Negative 12 over x to the 5th. Okay, so again, negative exponent means put this into the denominator. Okay, so let's say this problem started off with 3 over x to the 4th. Then you'd have to take this extra step. Okay. But like this, yeah. If the problem starts off like this, then you go like this. But if you want to simplify it, then this is what you would want. Okay, so I think that's what you want in the chat. If I'm wrong, ask again, but I think that's what you want. Whoops, made the chat too big. So let me minimize the chat. Okay, all right, so we're ready to do some problems. Let me show you these derivative formulas in the text. Okay, my text. Again, my text may not be yours. It's the 11th edition. Let's see if I can show that. Yeah, 11th edition. So my page 573, but yours is probably similar. Power rule. If f of x is x to the n, f prime is n x to the n minus 1. Okay, so you can catch that in the video later if you need it, but you know, I already wrote it down for you. Constant function. My page 575. If f of x is c, a number, then f prime of x is 0. Okay, notice they actually went through the proof by the limit definition. Okay, but you don't have to look at it if you don't want to. Okay, so the derivative of a constant function is 0. Then further down on page 575, the coefficient rule. If f of x is c times u of x, sorry, I can't get it to focus right. C times u of x, the derivative is c times u prime of x. A constant times a function, then the derivative is the constant times the derivative of the function, coefficient rule. Okay, they call it the coefficient rule. I call it the constant multiplier rule because that's the way it's stated in many texts. Okay, and the rule I just gave you is the sum and difference rule, bottom of 576. Okay, if you have something plus something, sum rule, if you want the derivative of the whole thing, just take the derivative of the first plus the derivative of the second. F prime of x is u prime of x plus v prime of x. Just differentiate all the way down the line. Okay, and look at the example they gave us. 3x squared plus 2x plus 11, right? So how do you differentiate? Take the derivative of the whole thing. Just give me the derivative of that, plus the derivative of that, plus the derivative of that, right? So the derivative of 3x squared is 6x, right? 6x to the 1. Derivative of 2x is 2. Derivative of 11 is 0, so you don't have to write it. And then the difference rule. If you have something minus something, page 577, if you're keeping score, f of x is u of x minus v of x, then the derivative is u prime of x minus v prime of x. So you want the derivative of the whole thing, just take the derivative of the first minus the derivative of the second. Okay, so that's all. All right, so one example here. How about this one? B, if you can read it. 4x cubed minus 2x squared plus 5x minus 3. So sums and differences, just take the derivative of this, minus the derivative of this, plus the derivative of this, minus the derivative of this. Okay, so 4x cubed, 4 times 3 is 12, so the derivative of that is 12x squared. Then the derivative of negative 2x squared is a negative 4x. The derivative of 5x is 5. The derivative of negative 3 is 0, so you don't have to write it. And that's about it. Okay. Okay, so we're ready. Okay, so 9.4, where are we? 1 to 20, 1 to 33, 47, 48, 53. We have to go up to 53. Okay, so for those of you that aren't getting the book, page 580. Trying to aim it so it's best focused. And some more there. And there. And there. I have to make it so you can see the directions also, I guess. Okay. Yeah, I don't have to hold it that long because you can always pause the video, right? Okay, you see that graphing calculator icon? Skip anything that make sure you use a graphing calculator icon. And let's see. That. And that. And we had to go up to 53, I guess. So we have some word problems. I think it was 47, 48, and 53. 47, 48, and 53 is way at the bottom. And unfortunately, that's not the end of the problem. Continues on the next page. And there we go. Okay. All right, so as usual, I show you even problems that are like the odd problems. Okay, so 9.4, page 580 in my book. Okay, number 2, f of s is 6. It's a constant. So what's the derivative? 0. F prime of s is 0. Okay, by the way, you should give me some derivative symbol. Don't just put 6 equals 0, right? If you show it to an algebra 1 student, so that's 6 equals 0. Of course, that's not true. Yeah, so you have to give some derivative symbol like f prime or dy dx. In this case, it would be dy ds, I suppose, or y prime, some derivative symbol. Okay. for s equals t squared. What's the derivative of t squared? 2t. S prime equals 2t. T to the 1, right? 2 minus 1 is 1. But if the exponent is 1, then we know we don't write it. Okay. Okay, 6. Y equals 12 plus 2x minus 7x cubed. So what's the derivative of the whole thing? Just give me the derivative of this plus the derivative of this minus the derivative of this. Derivative of 12, constant, 0. So don't write anything. Derivative of 2x, that looks like this one, mx. The derivative is just a coefficient, m. So the derivative of 2x is just 2. And then negative 7x cubed, negative 7 times 3, negative 21x squared. Okay. Pretty straightforward, I hope. Okay, 8. F of x is 3x to the 4th minus x to the 9th. So take the derivative of this minus the derivative of this. So 3x to the 4th, 12x cubed, minus x to the 9th, 9x to the 8th. Okay. Hopefully, as I'm doing it like this, as I'm pausing, maybe during the pause, think about what you would put down. And then if you get it right, great. Okay. 10, a little bit longer. 3x to the 5th minus 5x cubed minus 8x plus 8. Okay, so derivative. This time I wrote dy dx, but you can use any symbol for derivative. Okay, so I'll pause a little bit so you can think. What's the derivative of 3x to the 5th? 15x to the 4th. Okay. Then think about negative 5x cubed. What would you put down? Negative 15x squared. Derivative of negative 8x? Negative 8. Derivative of 8? 0. So you don't have to write plus 0 because if it's plus 0, you just leave it alone. Okay, so if you got exactly what I got, great. That's what you want. Okay. So if I give you questions like this on the quiz Thursday, hopefully you're okay. And again, you know, it's so low pressure. You can use your book notes. You can talk about it among your group mates and so forth, right? So very low pressure. Okay, 12. U equals 2t to the 10th minus 5t to the 5th minus 9. Okay. The symbol this time would be du dt for derivative. Okay. This very clearly tells you that the variables are u and t. Okay. You could also write u prime. Okay, so think to yourself, what would you put? Okay, 2t to the 10th. What's the derivative? Multiply, subtract 1. 20 t to the 9th. Did you get that? Okay, negative 5t to the 5th. Okay, multiply, subtract 1. Negative 25 t to the 4th. And the derivative of negative 9? 0, so you don't have to write anything, so you're done. Yeah, so this is u equals f of t. U is a function of t. So it's okay, instead of y and x, they give you u and t, we would say du dt. Okay, 14. A little bit harder, but nothing you can't figure out. H of x is 12x to the 20th plus 8x to the 10th minus 2x to the 7th plus 17x minus 9. So how do I differentiate? Take the derivative of the whole thing. Just give me the derivative of this plus the derivative of this minus the derivative of this plus the derivative of this minus the derivative, right? Just go down the line. Okay, 12x to the 20th. So 20 times 12, 240x to the 19th plus 8x to the 10th. Think to yourself what the answer might be. 80x to the 9th. Okay. And think about the next one. Negative 2x to the 7th. What should it be? Negative 14x to the 6th. Plus derivative 17x, 17. And derivative negative 9 is 0. So that's that. Okay, and yeah, let me raise it up again for focusing purposes. Maybe it wasn't completely focused. So I know I might be going fast here, but you know, when you look at the video, you can always pause, rewind, fast forward as much as you wish. So I know it's a little bit better focused this way. And they really should give me a document camera that allows you to focus. It wouldn't be such a bad idea, I guess. Whoops, move that over a little bit. Okay, 16 looks a little bit different. Let's look at the wording there, okay? Okay, find the slope of the tangent to the curve. B, the instantaneous rate of, so the answer to A and B is the same. So you take the derivative and plug in whatever they tell me to, right? So 16, I'm gonna plug in X is 3. So what about the 22? That's Y, but my expression doesn't have any Y, so don't worry about it. Likewise for 18, after I find a derivative, I plug in 1. So my answer to A and B is the same. Slope of the tangent, derivative. B, instantaneous rate of change, derivative. Okay, C of X is 3x squared minus 5. So derivative, 6x plus nothing, 6x. The point that they give me is 322, so now I plug in 3. So 6 times 3, 18. So the answer to part A and part B automatically are both 18, right? That's the way that works. Okay. $18 is somewhat similar. R of X is 16x plus X squared at X equals 1. Find the derivative, plug in 1. So R prime, derivative 16x, 16. Derivative X squared, 2x. Now I plug in 1. R prime of 1, 16 plus 2 times 1, 18. So the answer to part A and B, again, is 18. Wasn't the other one just also 18? Yeah, so coincidentally, we got the same answer here, unless the author somehow likes the number 18 for some reason. But anyway, actually, I'm just curious, are the other answers also going to be 18? They might very well be, but yeah, 17 should not be. But anyway, whatever. All right, so moving on, find the derivative. Now I noticed for 19, 20, 21, a lot of these problems already start off with a negative exponent. That means I can leave the answer with a negative exponent. I also see some weird fractions. So we'll take a look at that. Okay, 20. Y equals X at a negative 1 minus X at negative 2 plus 13. So what's the derivative? Okay, so negative 1. If it's negative 1, you just put a negative. X to the negative 2. Negative 1 minus 1 is negative 2. Plus 2. Can you see how come it's a plus 2? It's a negative 2 times, there's an understood negative 1 there. Negative 2 times negative 1 is a positive 2. X to the -3. Plus the derivative of 13 is 0. Okay. And yes, this time you are allowed to leave your answer like this because the problem started off with negative exponents. But again, if you want to keep going, I don't mind. So how do you keep going? Negative exponents go in the denominator. So -1 over x squared plus 2 over x cubed. So that's how you would do that. Okay, 22 has some pretty weird fractions. So we'll just go down the line. You just have to remember how to do your arithmetic essentially with fractions. So W is 5u to the 8/5 minus 3u to the 5/6 plus u to the 1/3 plus 5. So how do you take the derivative of the whole thing? Just give me the derivative of this minus the derivative of this plus the derivative of this plus the derivative of this. Okay, so 5u to the 8/5. I multiply, but if you multiply these two, 5 cancels out, right? So your new coefficient is 8. U to the 3/5, right? 8 over 5 minus 5 over 5 is 3 over 5. Okay, then this one, -3 times 5, 6. 3 partially cancels the 6, leaving me with a 2 on the bottom. So it's -5/2. Again, -3 times 5, 6. 3 cancels the 6, I got 5 over 2. U to the, okay, 5, 6 minus 1, that's like this. 5, 6 minus 6, 6, right? It's -1/6. Okay, and likewise, how do you differentiate u to the 1/3? 1/3 comes down. U to the 1/3 minus 1, 1/3 minus 3/3 is a -2/3. Okay, I have a negative exponent, negative exponent. Look at the original problem. Think to yourself, am I allowed to, by the rules of the game, am I allowed to leave my answer with a negative exponent? Look at the original. The original does not have any negative exponents. So this time you must not leave your answer like this. Now, if you do this on a test or quiz, I'll give you partial credit, but full credit, change the negative exponents to positive exponents by putting them in a denominator. Okay, so that's good, leave that alone. But this u to the -1/6 goes in a denominator, so -5 over 2 u to the 1/6 plus 1 over 3, and this comes down as u to the 2/3. So that's the best final answer. Okay. Then let's see, what do they want for 28? That kind of problem. Write the equation of the tangent line to each curve at the indicated point as a check graph both the function and tangent line. Okay, we won't bother doing that. But this is the one where you plug in and then do the point slope form. Okay, that's going to be a recurring theme for the rest of the semester, over and over and over again. We'll see that concept. Okay. So find the equation of the tangent line, that means derivative, at x equals 2. Okay, they don't give me the y value, but you can plug it in. So y of 2, y parentheses 2. Put a 2 here, a 2 here. So 2 to the 4th minus 4 times 2 cubed minus 2. 2 to the 4th, 2 times 2 times 2 times 2 is 16. Minus 4 times 8, 2 cubed is 8. So minus 4 times 8 is 32. Minus 2, that comes out to be -18. Is it 18 again? Well, it's a -18. So the point is 2, -18. That's my x1, y1 in the point slope form that I'm going to do later. Okay, point slope form, if you forget it, put it on your cheat sheet. Y minus y1 equals m times x minus x1. All right, so I have the y coordinate. Now I need the slope. Slope means derivative. So what's the derivative of x to the 4th? 4x cubed. That's a 3 there. Sorry if you can't see it. What's the derivative of -4x cubed? negative 12x squared. What's the derivative of negative 2? 0, so don't put anything. Okay, so this is the derivative anywhere. Now, what's the derivative at 2? I plug in 2. So 4 times 2 cubed minus, whoops, where am I? What did I do? I plugged into the wrong thing, it looks like. 4, let's see, 4 times 2 cubed, oh, here we are, minus 12 times 2 squared, right? So this is 4 times 8, which is 32. 12 times 4 is 48. 32 minus 48 is a negative 16. So that's a slope. Okay, so I got it. Point, slope, point slope form. Y minus y1 equals m times x minus x1. So y minus a negative 18, y minus y1 equals m, negative 16, times parentheses, x minus x1, x minus 2. And you may stop here, okay? If you were my Algebra 1 class, I'd make you keep going, but you've all had algebra, you know, intermediate algebra, elementary algebra. We know how to do this. We're focusing on the calculus right now. So you're allowed to stop right here. Okay. All right, let's look at 32, what the words say there. Find the coordinates of points where the graph of f of x has horizontal tangents. Horizontal tangent means the slope is 0. Okay. Horizontal tangent, m is 0 or y prime is 0. So maybe the graph looks something like this. Okay. You draw the tangent line, slope is 0. In other words, take the derivative, set it equal to 0 is the way to do it. Okay. So the function is 1/3 x cubed minus 3x squared minus 16x plus 8. So find the derivative. So f prime of x, what's 3 times 1/3? 1. Coefficient is 1, which means don't write it, x squared. Derivative of negative 3x squared is negative 6x. Derivative of negative 16x is negative 16. Plus 0, derivative of 8 is 0. Okay, since it says horizontal tangent, I set this equal to 0. Okay, factor. What two numbers have a product of 16 and a difference of 6? That's 8 and 2. X minus 8, x plus 2 equals 0. If you forward this back out, you'll get this. Let's check. X squared, right? Plus 2x minus 8x. So plus 2x minus 8x is minus 6, and then minus 16. All right, so by the 0 factor property, that means either this is 0 or this is 0. What number makes this expression 0? 8. What number makes this thing 0? Negative 2. Okay, so I'm not quite done, but I'll let you figure out the rest. It's a little bit clumsy, but you know what to do. Just plug in 8, grind it out, and plug in negative 2. So the answer is 8 comma something. Okay, plug in 8. It's messy, but you can do it. And likewise, plug in negative 2, grind it out, and you get that answer. Okay, so it's 8 comma something, negative 2 comma something. All right. Okay, then all I have left are some word problems, and then I'm actually finished. Let's see, 48, there's an even problem, 48, so let me show you that one. Even, so I'm guessing 47 is similar. And I'll get you set up for 53 also. So 48. R of x is equal to blah, blah, blah. What is the marginal revenue? Aha, marginal means derivative. When 40 units are sold, I plug in 40. And then B, interpret your answer to part A. Okay, so 47 is probably very similar. And for those of you that have the book, the answer's in the back. Okay, so marginal means derivative. Okay, and it looks like I messed up over here. So R is 300x minus 0.02x squared. So R prime, which means marginal. Derivative 300x is 300 minus 0.02x squared. So 2 times negative 0.02 is negative 0.04x. And now I'm supposed to plug in 40. So forget about this. I completely botched that. Yes, but 300 minus 0.04 times 40. Okay, and if you do it the right way, it's $298.40. This is the marginal revenue. Okay, so the revenue in selling the next item, which in this case is the 41st item, is $298.40. So that's what it means. Okay, the last problem is 53, and then I'm done. Although it'll take a while to finish that one, I think. Oh, yeah, maybe I have time to go back and do number 30 also, but let me show you 53. So even though I'm sort of down to the last problem, I'm not quite finished, but maybe 5-10 minutes at the most. Cost and average cost. You have a cost function, C of x is equal to 4,000 plus 55x plus 0.1x squared. Turn the page. Average cost. Average cost, C bar, that bar over it, is total cost divided by x. So you have a new function. They divided the original by x, 4,000 over x plus 55 plus 0.1x. Find an instantaneous rate of change derivative of the average cost with respect to the number of units produced. So they want the derivative of this guy. B, find a level of production at which this rate of change equals 0. So that's just like the previous problem, set the derivative equal to 0. B, at the value find in part B, find an instantaneous rate of change of cost and find the average cost. What do you notice? Okay, so what does he mean by that? So here's the original. C bar means divide all of this by x. So 4,000 divided by x. 55x divided by x is just 55. And 0.1x squared divided by x is 0.1x. Okay, so rewrite this as 4,000 x to the negative 1, right? If an x is in the denominator, write it as 4,000 x to the negative 1 plus 55 plus 0.1x. Find this derivative. They call it C bar. So C bar is for average cost. Maybe I should put that for emphasis. Average cost. C bar. Okay, so what's the derivative of this? Negative 4,000 x to negative 2. Derivative 55 is 0. Derivative 0.1x is 0.1. Clean it up. Negative 4,000 x to negative 2 means over x squared plus 0.1. All right, now they want us to set that equal to 0. Okay, when is this equal to 0? So set it equal to 0. Add this to both sides. Add 4,000 over x squared to both sides. Okay, I know that 0.1 is 1/10, just to make things easier on me. Okay, so I write it as 1/10 is 4,000 over x squared. I cross multiply that times that equals that times that. X squared equals 40,000. Take the square root. X is 200. Okay, then after that, they're asking for a C bar of 200. They want you to plug in 200. So I'll let you figure that out, but I'm telling you what to do. So plug in 200 to C bar. Plug in 200 there and there. Okay, the upshot is that the answer to part C is that they're supposed to be equal. Okay, if I plug in 200 to here and 200 to here, they're going to turn out to be the same. Okay, so I'll let you verify that on your own. I don't want to give you too much, but yeah, that's that. Okay, and yeah, I have time. Let me go back and do number 30, and then I'm finished. Okay, so I'll be done in about 3 more minutes. So if you have any questions, you can bring it up. Otherwise, we're done. Okay, so you should be okay, I hope, on a quiz on Thursday on this kind of stuff. Okay, next time we have more rows. I'll just tell you ahead of time. The product row and the quotient row, 9.5. Product means what? Multiplication. Quotient means division. So how do you take the derivative if you see a product or a quotient? We'll see that next time. But let me go back to number 30. Okay, find the equation of a tangent line at the given point. F of x is x cubed over 3 minus 3 over x cubed at x equals -1. Okay, so again, by my doing the evens, it should show you how to do the odd ones that are nearby. All right, I'm going to write this as 1/3 x cubed. Dividing by 3 is the same as multiplying by 1/3, right? So 1/3 x cubed minus, in order for me to do the power root, I got to bring this upstairs. So minus 3x to the -3rd power. Okay. First, I notice to do the point slope form, I need a point. They only give me the x coordinate. How do I find the y coordinate? Plug in. So f of -1 let's see. Actually, I think I goofed here. I'm supposed to put f of -1. My bad. It's negative. So -1 cubed, that should be -1/3. And negative, that should be a positive. So it's positive 8/3. Okay, let's see. Plug in -1. -1 cubed is -1, so it's -1/3. And -1 cubed is -1, but there's a negative there, so it's positive. So it's -1 comma positive 8/3. Sorry. And yeah, that's going to make this messed up. So this should be a minus. Minus. Make it look like that's an arrow there. So I found the point. Now I need the slope. So what's the derivative of this? 3 times 1/3? 1. X squared. So just x squared. Derivative of this? -3 times -3, positive 9. X to the -3 minus 1 is -4. And negative exponent, bring that downstairs. X squared is fine, just leave that alone. But x and -4, write it as 9 over x to the 4th. Now I plug in -1. So -1 squared, 1. -1 to the 4th power is 1. So 1 plus 9 over 1, that's 1 plus 9, or 10. Okay, so point, slope. Point slope form for the equation of the line, y minus y1, y minus 8/3 equals m, 10. Derivative means slope, slope of the tangent line, parentheses, x minus a minus 1, x plus 1. And there we go. And that's that. Okay. So I finished what I was going to present to you for today, folks. So mark off 9.4. Next time we have 9.5 and quiz on Thursday. We'll only run today's stuff, 9.4 at the end of class on Thursday. Okay, so I'm finished, folks. Anybody have any question? You can either unmute yourself or put it in the chat. Otherwise, we're going to call it a day. Okay, so anybody with any questions, please. Wait just for a moment. Okay, I don't see anything and I don't hear anything, so we'll call it a night, folks. All right, so have a good night and we'll see you all next time. Okay, good night, everybody. Bye.
Thank you.
Thank you.
Thank you.